Hi, we are presenting AI Climate Resilience Sandbox, an interactive scenario planning tool for exploring climate risks and adaptation strategies. Our project focuses on ENSO-driven drought and water stress, especially conditions linked to events like El Nino. These events can affect rainfall, heat stress, crop yields, reservoir storage, and groundwater pressure. This tool is not a weather forecast, it is a planning sandbox that helps users ask what would happen under a severe climate scenario and which adaptation measures might reduce the risk. Many climate tools focus on monitoring on forecasting conditions, but local planners, NGOs, agricultural teams, and water resource managers also need simple tools to compare response options before a crisis happens. For example, if rainfall drops sharply and drought lasts several months, should a region prioritize drought-resistant crops, groundwater rationing, supplemental irrigation, water conservation, or a combination of strategies? That is the gap our project tries to address. This app is built in Streamlit using Python. It combines historical climate, agriculture, and reservoir data for Tamil Nadu from 1991 to 2017 with lightweight machine learning models and transparent rule-based scoring. Users can adjust climate inputs from the sidebar. Here is our dashboard. Users can adjust climate inputs from the sidebar, including sea surface temperature anomaly, monsoon rainfall deficit, drought duration, and heat stress. They can also enable drought-resistant crop program, emergency groundwater rationing, supplemental irrigation, and water conservation. So first I'll start with the default scenario. The app shows key indicators such as crop yield stability, water reservoir security, groundwater stress, agriculture risk exposure, and regional resilience score. Now I'll increase the severity of the climate scenario by selecting an extreme ENSO shock. The dashboard updates to show how the scenario affects risk. The regional map gives a visual overview of risk distribution, while the alerts section translates the model output into planning categories such as normal, elevated, severe, or critical. Here, the adaptation measures are already turned on. I'll quickly adjust the preset to moderate. When I enable drought-resistant crops and other adaptation measures, the radar chart shows compares outcomes with current adaptations against the without adaptations baseline. This helps users see how different measures may improve resilience indicators under the same climate stress. And the recommended strategies section ranks adaptation combinations and provides short explanations. These recommendations are connected to a knowledge base using JSON files rather than being hard-coded directly into the app. So a key part of this project is transparency. The app includes Z-score thresholds, historical means, confidence ranges, and out-of-distribution warnings. If a user creates a scenario beyond the historical data range, the app warns that the results should be treated as exploratory. This matters because our dataset is limited. The current version uses 27 early records, so the model is not meant to make precise forecasts. It is meant to support scenario exploration and planning discussions. This app can also export an action briefing. Um, the report includes scenario parameters, active adaptation measures, key indicators, and recommended strategies, and the disclaimer that the tool is for decision support only. Um, Also, there are important limitations. This is not an operational forecast. It does not predict future climate events or issue official drought declarations. Some indicators are simplified proxies and adaptation effects. are planning assumptions rather than validated casual estimates.